Welcome back to Models and Agents, episode 18 for March 20th, 2026. Your daily AI briefing on the models and agents that are actually changing how we build intelligent systems. And no, not those kinds of models and agents. Let's get into it. Let's start with what I think is the most immediately useful release this week. LlamaIndex has dropped LiteParse, a spatial PDF parser specifically built for agentic RAG workflows. If you're building agents that need to read contracts, research papers, financial reports, earnings transcripts, or technical manuals, this one is going to save you a surprising amount of pain. Here's the deeper context. Even though frontier models have gotten dramatically cheaper and faster, the data ingestion layer has remained one of the biggest bottlenecks and sources of error in production agent systems. Most existing PDF parsers flatten documents into linear text streams, completely destroying layout information, table structures, reading order, and spatial relationships. That loss of structure forces the LLM to guess what belongs with what, which leads to brittle reasoning downstream. LiteParse takes a different approach. It's designed from the ground up to preserve spatial and hierarchical relationships in complex documents. Instead of treating a PDF as a wall of text, it gives your agents a much richer, layout-aware representation. The library ships both as an easy-to-use CLI that you can start playing with today and as a TypeScript-native library that drops cleanly into existing LlamaIndex agent flows. My take? This is the kind of focused, high-leverage infrastructure work the ecosystem desperately needs. I expect we'll see rapid community extensions, things like better table understanding, figure caption linking, and even native support for scanned documents. If you're doing any serious document-heavy agent work, go try the CLI on your worst PDFs this week. You'll probably see an immediate jump in reasoning quality. Now, while we're on the topic of improving RAG reliability, several strong research papers dropped this week that tackle different failure modes in agentic and retrieval systems. One particularly interesting paper evaluated 5 different LLMs against human performance using the strange stories paradigm, a well-established test from developmental psychology designed to measure theory of mind. Earlier and smaller models were heavily thrown off by the number of inferential steps required and were extremely vulnerable to distracting or misleading information in the prompt. In contrast, GPT-4o showed high accuracy and remarkable robustness. It performed comparably to human controls even on the most difficult conditions. This isn't just another benchmark, it's one of the cleaner demonstrations we've seen that scale actually produces qualitatively different cognitive capabilities, not just incremental improvements. The gap between smaller models and frontier models on this task is larger than most people in the industry expect. Worth testing yourself if you're evaluating models for tasks that require social reasoning or nuanced understanding of intent. Another notable paper introduced PowerFlow, which reframes unsupervised fine-tuning as a distribution matching problem using G-flow nets. The researchers developed a length-aware trajectory balance objective that lets you explicitly control the shape of the output distribution. Want stronger, more rigorous reasoning? Increase alpha above 1. Want more creative exploratory outputs? Dial alpha below 1. What's impressive is that PowerFlow consistently outperforms existing RLIF-style methods and, in some cases, even beats supervised GRPO. This feels like a meaningful step toward more controllable post-training techniques that don't require massive preference datasets. On the trustworthiness and safety side, researchers released Construct, a new method for scoring the trustworthiness of LLM structured outputs, down to the individual field level. The really nice part? It works without needing access to log probs, without any training data, and without custom model deployment. It handles complex, nested JSON schemas gracefully and outperformed other scoring approaches on a new public benchmark that includes both Gemini 3 and GPT-5. Let's move over to agent and tool use developments. One of the more elegant papers this week is DynaRAG. It offers a smart, lightweight way to bridge static retrieval and dynamic knowledge. The system uses an LLM re-ranker and a sufficiency classifier to decide whether the retrieved documents are good enough. If they're not, it intelligently calls external APIs using Gorilla V2 for tool invocation. The results on the CRAG benchmark for dynamic questions are strong, and it also meaningfully reduces hallucinations. If you're building agents that need to stay current on fast-changing information, pricing, inventory, regulations, news, the DynaRAG pattern is worth experimenting with. Google also made a quietly significant move this week by expanding its Universal Commerce Protocol, UCP. They've now added shopping cart functionality, richer catalog capabilities, and identity plus loyalty features. This gives AI shopping agents persistent state across sessions and much more powerful commerce primitives to work with. This matters. Most current shopping agents are still quite brittle because they lack proper state management and standardized ways to interact with retail systems. Google's expansion of UCP feels like a meaningful step toward truly autonomous retail agents that can actually complete complex purchases end to end. We'll see how quickly other major retailers adopt or respond to this protocol. On the practical RAG engineering side, two techniques stood out. The first is a new framework for controllable evidence selection using deterministic utility gating. Instead of letting the model decide what evidence to use during generation, this approach uses two estimators, meaning utility estimation and diversity utility estimation, to make evidence selection deterministic and auditable before answer generation even begins. It only accepts sentences that explicitly satisfy required facts or conditions. The transparency win here is huge. If you care about building RAG systems that auditors or regulators can actually trust, this direction is very promising. The second is UCPOF, uncertainty-calibrated prompt optimization. It combines a log-scale focal uncertainty metric with first token uncertainty estimation. The practical results are excellent, roughly 6% higher accuracy over few-shot baselines, while beating full RAG systems and cutting retrieval calls by over 50%. That's the kind of efficiency gain that actually moves the needle in production. Finally, for those working on clinical or mental health applications, Therapy Gym introduces a serious evaluation framework for therapy chatbots. It measures adherence to proper CBT techniques using the cognitive therapy rating scale while also assessing safety risks. Models trained with CTRS and safety rewards jumped dramatically from 0.17 to 0.60 on expert ratings. The benchmark also includes Therapy Judge Bench for better calibration against human clinicians. This is the kind of domain-specific evaluation work we need a lot more of. Before we finish, I want to spend a few minutes on something that rarely gets discussed openly but quietly kills most agentic RAG projects. Everyone talks about agentic RAG like the main challenge is just making the LLMs smarter. In practice, the real killers are silent failure modes that don't cause obvious crashes but destroy both performance and cost efficiency. The three big ones are retrieval thrash, tool storms, and context bloat. Once you give an agent a loop and multiple tools, its behavior stops being a single forward pass and becomes an actual search process. Retrieval thrash happens when the agent keeps pulling overlapping or low-value document chunks because its stopping criteria are too weak. Tool storms occur when the agent starts calling 15-plus tools in a row without making meaningful progress, often because each tool call slightly shifts the context and resets its sense of direction. Context bloat is the inevitable result. Your prompt balloons to 100,000 plus tokens of mostly redundant information. These problems are insidious because they're invisible in simple end-to-end accuracy metrics. You can have an 85% success rate while burning 7 times more inference budget than necessary. The engineering reality is that you need explicit monitoring for these 3 failure signatures from day 1, repeated retrieval of similar documents, tool call chains longer than 6 or 7 steps, and dangerous context growth rate. The biggest gotcha I see is teams treating these as model problems instead of system problems. Better models help at the margin, but the real wins come from adding early detection, hard step budgets, utility-based retrieval gating, and explicit anti-thrash mechanisms in the agent loop. When you're building agentic RAG, instrument these 3 metrics first. Everything else is secondary. Here are the things you should actually try this week. Run LiteParse on your worst, most layout-heavy PDFs, especially contracts or research papers. You'll likely see an immediate improvement in agent reasoning quality. If you work with time-sensitive or rapidly changing information, prototype a DynaRAG-style pattern. Add a simple first token uncertainty check, about 50 lines of code, to your RAG pipeline inspired by UCPOF. Many teams are cutting retrieval costs in half with this. Run your structured output pipeline through a construct-style trustworthiness scorer to see where human review effort is best spent. Test GPT-4o versus smaller models on theory of mind tasks using the Strange Stories dataset. The gap is bigger than most builders realize. On the horizon, I expect to see more production-focused agent monitoring tools emerge as research on retrieval thrash and tool storms gets turned into actual open-source libraries. We'll also see continued rapid iteration on document intelligence and PDF parsing following LiteParse, plus growing adoption of uncertainty-aware and deterministic RAG techniques that simultaneously reduce cost and increase reliability. That wraps up today's briefing. If you found this useful, share it with a developer or builder who's deep in the trenches with you. Subscribe wherever you listen, and I'll see you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.